Hi and welcome to another Carpenter Tutoring tutorial. I'm Amy and today we are going to talk about some of the properties of multiplication. Now, an important caveat on this topic is that 9 times out of 10, you're not actually going to need to know the names of these different properties. You'll just have to be able to use them in your multiplication problems. The only time that this is not true, most textbooks and classes have a chapter or a unit in which you have to tell the property that allows you to take the step that you did in your problem. If you happen to be in that chapter or that part of your class, then trying to remember the names will be a good plan. But if you're beyond that section, or if you have the names down pat and you just need a better understanding of what the properties themselves actually mean, you can focus on the impact of those properties more so than the names. We'll start out with the commutative property of multiplication. Commutative is a bit of a tongue twister, but it makes me think of the word commute, which means to move around, and that's a good way to remember what this property tells us. What the commutative property says is that the order of numbers in a multiplication problem, assuming the only operation we're using is multiplication, the order doesn't matter. So if I have 7 times 5 times 3, that's the same thing as 3 times 7 times 5, or any other order of these values that I might come up with. In other words, the order of numbers in multiplication does not matter. You can put them in any order you want. Up next, we have the associative property, which I think of as being sort of the social property, saying that everybody can be together. So again, a caveat for this one is assuming that the only operation we're using is multiplication. So with that understanding, let's say that we have a 3-part multiplication question and 2 of our terms are inside grouping symbols. So something like 3 times 8 times 9, where 3 times 8 is inside parentheses. What this tells me is that the parentheses aren't actually doing anything. They don't change the order of operations because there aren't any other operations for us to change the order of. So I can actually place these grouping symbols or parentheses wherever I want to. Even if I did 3 times the quantity 8 times 9, my product would still come out to be the same. Another way that we can think about this one is that with the associative property, if you see that you have all multiplication and there are some values inside parentheses, we can actually remove those parentheses and think of this, for this example, as just 3 times 8 times 9 with no grouping symbols whatsoever. Now that we've removed these grouping symbols, it actually becomes a commutative property problem. Up next, we have the identity property of multiplication, which tells us how we can stay true to ourselves, how a value can stay unchanged when you're multiplying by a particular value. So the only way that a value can stay unchanged through multiplication is if you multiply by 1. So what this tells us is that any value multiplied by 1 will come out to be the original value still. So if I have 7 times 1, my product stays 7. If I have 372 times 1, my product stays 372. And even if I have something crazy with variables like -7 ab to the third c times 1, my product is still -7 ab to the third c. So the takeaway here is that anytime you multiply by 1, we don't create any change to the original value. Finally, we have the inverse property of multiplication. An inverse makes me think of opposites. Now, in this case, opposite does not refer to signs, so we're not talking about positive versus negative. What we are talking about is position in a fraction. So what the inverse property of multiplication tells me is that if I have a fraction, let's use 3/5 as an example, and multiply it by its reciprocal, the fraction in which 5 is now the numerator, and 3 is now the denominator, then the answer will always be 1. That's because I have 3 times 5 on the top and 3 times 5 on the bottom, so I end up with 15 over 15, which simplifies out to 1. This works even if we start with a whole number. So if I start with something like 2, I can always think of this whole number as a fraction by putting it over 1. So that means I can do 2 over 1 times 1 over 2 and still have a product of 1. So what this guarantees us is that any time that we start with a value and multiply it by its reciprocal, we will always have a product of 1. I hope it's been helpful to work through some of these problems and properties together. As always, if you have any questions or other topics that you'd like to see covered, please let me know down in the comments. If you enjoy our content, I hope you'll consider liking this video and subscribing to our channel. Thank you so much for spending part of your day with me, and I'll catch you next time.